Greetings and welcome to the series of lectures on systems of equations, 4.5 Introduction to Determinants. So this lecture is not necessarily what a determinant stands for or what it means. It's mostly how to calculate a determinant. So a determinant, we're just going to take it as a useful value, and we can calculate it from a square matrix. Square matrix is just a set of values set up in a square. So same amount of columns as rows. So for a 2 by 2 matrix, it's used to represent the coefficients in a system of linear equations. Some future lectures will actually go through building matrices from a system of equation. This is just to calculate determinants. So what is it? Here's how I calculate a determinant. I set up a matrix, and we'll just say they're generic numbers A, B, C, D, and it has these two straight lines around it, and that's how we know we're going to calculate a determinant. You take the diagonals A times C and you subtract the other diagonal B times D. So AD times BC. Okay? AD minus BC. So let's try and find a value of it, the determinant. Given the matrix 1, 2, 3, 4, we're going to take the diagonals 1 times 4 minus 3 times 2. 1 times 4 is 4, 3 times 2 is 6, so 4 minus 6 is negative 2. The determinant of the square matrix 1, 2, 3, 4 is negative 2. Let's try another one. The matrix 3, 5, negative 2, 7. Take the diagonal 3 times 7 minus negative 2 times 5. 3 times 7 is 21. Negative 2 times 5 is negative 10, but subtract a negative 10 means add 10. So 21 plus 10 is 31. A little bit more complex problem. We have a few unknowns here, so let's see if we can solve for x in this matrix by using the determinant. X squared 2, x1, and this determinant equals 8. So let's solve for x. How do I work it? Well, take the definition of the determinant, x squared times 1, minus the other diagonal, x times 2 is 2x, that equals 8. X squared minus 2x equals 8. And I have some processes that I have learned in the past. I'm going to subtract 8 from both sides to set it equal to 0. See if we can factor x squared minus 2x minus 8. All right, negative 4 and positive 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So I know I factored correctly. Now I'm going to set both of these up using my zero factor property. X minus 4 will equal 0, and x plus 2 will equal 0. Therefore, my x value is either 4 or negative 2. Either one of these values, if I plug them back into the matrix and have one matrix look like 4 squared, 2, 4, and 1, that should equal 8, as well as negative 2 squared 2, negative 2, 1, that should also equal 8. And I'll leave that for you to work out on your own to see if indeed it really does check out. Now that's great if we have a 2 by 2 matrix, but matrices are not limited to just 2 by 2 matrices. Here we have a 3 by 3. So how do I calculate a 3 by 3 determinant? Well, here's the big long formula. It's going to be A1 times B2 times C3 plus A3 times B1 times C2 plus A2 B3 C1, okay, minus, ready? All right, A3 B2 C1, That's that diagonal. Then it's minus A1, B2, B3, C2. You can see it gets confusing really quickly. And minus A2, B1, C3. That's really complex, right? There's an easier way of looking at this, in my opinion. Easier way. Here's what you do. First method we have is you have the matrix, just generic A1, A2, A3, B1, B2, B3, C1, C2, C3, and you rewrite the first two columns over again. Now, this whole first part are the new diagonals. A1 times B2 times B3, A1 times B2 times C3. That's that term. A3 times B1 times C2 is the second term. A2, B3, C1 is the third term. Okay. Those are all addition. Using the same matrix and rewriting it over again, if we go in the opposite diagonal, we subtract it. A3, B2, C1, B3, C2, A1, and C3, A1, B1, those are the next three terms. Okay? But we're going to subtract them. Okay? That's how we came up with that big, long equation. I think it's easier to visually see the straight diagonals versus trying to remember which combination goes with which. All right, let's put it into play. First step is I'm going to rewrite the first two columns, 1, 2, 4, and 3, 0, negative 1. And now I'm going to multiply the column, the diagonals. All right. So I'll use blue for the positives that we're going to say add, 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 and I'll use green for the subtraction, subtract, subtract, subtract. All right, first diagonal. 1 times 0 times 1 plus second diagonal. 3 times 1 times 4. Third diagonal, negative 2, 2, and negative 1. Negative 2, 2, negative 1. Okay. Now going the other direction are going to be my subtraction. 4 times 0 times negative 2 is subtract 4 times, how about that? 0 times negative 2. Subtract negative 1, 1 times 1, subtract 1 times 2 times 3. Okay. Those are all my combinations. Okay, so let's do the math now. Go. All right, 1 times 0 times 1 is 0, plus 3 times 1 times 4 is 12, plus negative 2 times negative 1 is positive 4, minus 4 times 0 times 2 is 0, minus negative 1 times 1 is negative 1, and subtract 1 times 2 times 3 is 6. Almost there. 0 plus 12 plus 4 is 16. Minus 0 is still 16. Minus a negative 1 is 17. Minus 6 is 11. Okay, so the determinant for this 3 by 3 matrix is 11. Okay, so the first method was you rewrite the first two columns and the diagonals down will be addition and the diagonals up will be subtraction. That's method 1. Method 2 is we're going to expand by its minors. Here are the minors. The minors in a 3 by 3 matrix is the determinant consisting with the element that we choose and the remaining values, the determinant of the remaining values that when you eliminate the column and row that element sits in, it's that determinant. Yeah, that was sounding very confusing, but let me show you. I think it will make sense after I show you. So here's our determinant. Or here's what we're looking for, our determinant for a 3 by 3 matrix, A1, A2, A3, B1, B2, B3, C1, C2, C3. The minor element for A1 is the determinant. When you put your finger over A1, cross out the row that it's in, the column that it's in, and it's the remaining values. It's the determinant of the remaining values. So it's the determinant of B2, C2, B3, C3. Right? The minor for B1 means I kind of cover up B1 and that column and that row, and whatever is left over, if I take the determinant of that, that's the minor of B1. So it would be the determinant A2, A3, C2, C3. So the minor for C3, I cover that up. Any column consisting of C3, any row consisting of C3. So the determinant of A1, A2, B1, B2 is the minor for C3. Every single element has a minor, right? So if I visually said A1, and I can only do this once I mark up my paper, that's it. Okay, so for A1, here's my element A1. I cross out both the row and column that it belongs to, and the remaining values, the determinant is the minor for A1. Okay, the minor is the determinant result. But that's not the only information that we need. So the minor information is one thing that we need. The second information for method 2 is we need to know the sign array. So here's what the sign array is. It literally is the same size matrix, starting with positive, alternating positive, negative, positive, negative. We work ourselves through the matrix. So positive, negative, positive, negative, positive, negative, positive, negative, positive. Right? That is the sign array. Now, it doesn't mean anything yet, but we are going to utilize this information as well as knowing what the minor element, the minor for any element is. We're going to use those two facts to create a process to find the determinant of a 3 by 3 matrix. So hang tight. Okay, so here's what we're going to do. One, we're going to choose a row or a column to expand about. We're going to write the product of the element and its minor for each of the row or column that we selected, for each of the elements in the row or column that we selected in step 1. So if we choose to expand about a row, we're going to choose each element in that row and multiply the element by its minor. Then we're going to connect those products in step 2 with the signs from the sign array. For example, if we choose row 1, we're going to connect them by addition, subtraction, addition, meaning plus, minus, plus. If we chose row 2, it would be minus, plus, minus. And if we chose row 3, it's going to be plus, minus, plus. Likewise for any of the columns if we decide to expand around those. Talking's fun and dandy, but let's actually apply, right? So we're going to expand around row 1, and using the sign array of row 1, plus, minus, plus, we're going to figure out the determinant. Element in the first row is what we're going to expand around. So we take the element, 1, and we multiply by the determinant of its minor. Its minor is 0, 1, negative 1, 1. Okay, its minor is 0, 1, negative 1, 1. Our second element, 3, its minor is, if we take out the row and take out the column, it leaves 2, 4, 1, 1. 2, 4, 1, 1. Third element in row 1 is negative 2, and its minor, if we take out that row and that column, that leaves 2, 4, 0, negative 1. And now we use the sign array to connect all of them. Plus, minus, plus. Now we just have to figure out these determinants. Right, it's going to be 1 times, remember the diagonals, minus the other diagonal. 0 times 1 minus negative 1 times 1. Minus 3 times 2 times 1 minus 4 times 1 plus negative 2 times 2 times negative 1 minus 4 times 0. Let's do what's inside each of the parentheses first. 0 times 1 is 0. Minus negative 1 times 1 is negative 1. Minus 3 times 2 times 1 is 2. 4 times 1 is 4. Plus negative 2. 2 times negative 1 is negative 2. Minus 4 times 0 is 0. Let's keep simplifying. 1 times, well, 1 minus a negative 1 is, well, a minus negative 1 is a positive 1. Minus 3 times 2 minus 4 is negative 2. Plus negative 2 times negative 2 or minus 0 is negative 2. Getting there. All right, 1 times 1 is 1. Negative 3 times negative 2, I'll just say minus negative 6 for now. Leave that sign there from the sign array. Plus, negative 2 times negative 2 is 4. A minus negative 6 is a positive 6. And therefore, 1 plus 6 plus 4 is 11. Okay. That is exactly the same value we got before. I'm not too sure if you like this method better than the first method when we did the full diagonals in each direction. But once you get the hang of it and you practice it a little bit, I think the second method is pretty clear. You know? But it's just practice. Practice, practice, practice. Let's try another one. This time we want to expand down column 2. And it turns out the sign array for column 2 is minus plus minus. Right? So let's work with the second column. Minus from the sign array. 3 with its minor. If I cover up 3 in that column, that leaves 1, 1, 1, negative 1. 1, 1, 1, negative 1. From the sign array, a plus. Next element is a 4 with its minor. If I pull out this row and this column, that leaves 2, negative 2, 1, negative 1. Right. Last element of that column is 5, and my last sign array, the sign for my sign array is a subtract. 5 with its minor. Cover up that, it leaves 2, 1, negative 2, 1. 2, 1, negative 2, 1. Now I got to figure out those determinants. All right. Negative 3 times diagonal 1 times negative 1, subtract 1 times 1. Now, plus 4 times its determinant of 2 times negative 1 minus 1 times negative 2 minus 5 times the determinant, which is 2 times 1 minus 1 times negative 2. If you can do this in your head, you can go ahead and do it in your head. I'm just writing down all the steps. I want to simplify this as much as possible. Negative 3 times 1 times negative 1 is negative 1. 1 times 1 is 1, but subtract 1. Plus 4 times 2 times negative 1 is negative 2 minus 1 times negative 2 is negative 2 minus 5 times 2 times 1 is 2 minus 1 times negative 2 is negative 2. All right, getting there. 3 times negative 1 minus 1 is negative 2. 4 times negative 2 minus 2 is really going to be negative 2 plus 2, therefore that is 0. 2 minus a negative 2 is really 2 plus 2, so it's 5 times 4. Okay? All right. Negative 3 times negative 2 is 6. 4 times 0 is 0, and negative 5 times 4 is negative 20. Therefore, the determinant is negative 14. Once you get the hang of it, it's not too bad. The math part is not the hard part. Let's face it, we're only multiplying, subtracting, and adding. The more difficult part of this is figuring out which element, what goes along with the minor, and how to figure out a determinant after you get the minor. So let's say that you are a scientist and you're not too sure what the formula of the conversion of Fahrenheit to Celsius is, although we do know that it's F equals 5 over 9C plus 32. Let's keep that in the back of our head. But by doing some experiments, you figure out that if you have the Celsius temperature of 5, that relates to the Fahrenheit temperature of 41. And if you have the Fahrenheit temperature of negative 10, that's the Fahrenheit temperature of 14. And it's this kind of one-to-one relationship, so you just put it in another column as 1, 1, 1. And you set all of this equal to 0. Right? So you have this 3 by 3 matrix. You set it up for 0. And you want to see if indeed the information that you visually gathered, is that the formula F equals 59C plus 32. So let's see if this will actually work. And I'm going to use method 2, I think, on this instead of rewriting the two columns again. I'm going to go ahead and use method 2. And I'm going to use the first row and expand upon the first row. All right. Remember that our sign array is going to be plus minus plus. So it's plus C times its minor, 41, 1, 14, 1. 41, 14, 1, 1. Minus second element, F, times its minor. If I cover up that row, or that column, then that leaves 5, negative 10, 1, 1. 5, negative 10, 1, 1. Plus third element times its minor. Cover up that row. That leaves 5, negative 10, 41, 14. 5, negative 10, 41, 14. And all of this is supposed to equal 0. Okay. Let's figure out our determinants. It's going to be C times 41 times 1 minus 14 times 1 minus F times 5 times 1 minus negative 10 times 1. Okay. So Maybe a little long, but hang in there. Plus 1 times 5 times 14 minus negative 10 times 41, and all of this equals 0. Okay, all of it equals 0. I'm going to do the math in each of these parentheses. C times 41 times 1 is 41. 14 times 1 is 14. 5 times 1 is 5, minus negative 10 times 1 is negative 10, plus 1 times. 5 times 14 is, let's see, 5 times 14, all right, 14 times 5, 0 to 12? No, 70. 70. And negative 10 times 41 is negative 410. All of that should equal 0. Right? Now, let's clean it up a little bit more. 41 minus 14 is going to be 27. Minus f times 5 minus a negative 10 is really 5 plus 10, which is 15, plus 1 times 70 minus a negative 410 is really 70 plus 410, which is 480, equals 0. Our goal is to see if our observed information will land us with f equals 59c plus 32. Keep our goal in mind. All right, I'm going to rewrite this to where it's 27c minus 15f plus 480 equals 0. I want to solve for f. All right, so 27c plus 480 equals 15f. Divide everybody by 15. That's going to give me 27 over 15c plus 480 over 15 equals f. I can reduce both of these fractions. 3 goes into 27 9 times. 3 goes into 15 5 times. And 15 goes into 480 32 times equals f. So indeed, that matrix will give us the equation that we were looking for, right? Our observed information did indeed line up with the actual formula. So that's it for this lecture. Until next time, be seeing you.